Ever thought a simple wire could have so many secrets? Behind the scenes of every electrical connection, whether it's in your room, a factory, or a giant transmission tower, there's one unsung hero doing all the heavy lifting, the conductor. But not all conductors are made equal. Today, we're diving into the world of solid, stranded, and bundled conductors, and trust me, the deeper we go, the more interesting it gets. Let's start with the most basic form, the solid conductor. This is exactly what it sounds like. A single continuous piece of metal, usually copper or aluminium, with no twists, no internal divisions. It's one solid core, simple to produce, cheap to install, and highly reliable for static applications. You'll mostly find solid conductors in places where wires stay in place, like inside walls, electrical switchboards, or small power distribution systems. Their strength lies in their low resistance, less oxidation, and easy connectivity. But they also come with limitations. Solid conductors are stiff and brittle when bent repeatedly, so they aren't suited for areas with movement or vibration. And when we talk about large-scale power transmission, solid conductors simply don't make the cut. Too rigid, too heavy, and too impractical. Now I want you to comment below. Have you ever seen a solid core wire being used? Maybe in a switchboard or a simple home circuit? Now let's talk about the stranded conductor. This is made by twisting several small wires together to form one larger conductor. The materials are usually the same, copper or aluminium, but the construction changes everything. Stranded conductors offer high flexibility, better mechanical strength, and are less likely to break when bent or vibrated. That's why you'll find them in machine wiring, flexible cables, underground cables, and even in many power distribution lines. Another big advantage? If one strand fails or breaks, the others can still carry the current, giving you built-in redundancy. Also, the circular shape formed by the strands helps maintain a more uniform cross-section, which improves performance under varying loads and conditions. On the flip side, they are slightly more expensive to manufacture, and because of the small air gaps between strands, they can be more prone to corrosion in certain environments. Here's a question for you all. If stranded conductors are more flexible and reliable, why do you think solid conductors are still being used? Let me know in the comments. Now comes the heavyweight of high-voltage transmission, the bundled conductor. This is used when we're dealing with extra-high voltage and ultra-high voltage systems, typically 220 kV and above. In these applications, just increasing the thickness of one conductor isn't enough. Instead, engineers use 2 or more conductors per phase, placed a short distance apart and connected using spacers. This is what we call a bundled conductor. Why go through all this trouble? Because at very high voltages, a phenomenon called corona discharge becomes a serious problem. Corona causes power loss, noise, and radio interference. Using bundled conductors increases the effective surface area of the conductor, which reduces the electric field intensity and significantly lowers corona losses. There's more. Bundled conductors also reduce inductive reactance, minimize voltage drops, and improve transmission efficiency over long distances. You'll often see 2, 3, or even 4 conductors per phase, depending on the system voltage. So next time you see a giant transmission tower, take a moment and count. Are there multiple conductors per phase? That's bundling in action. Can you guess the number of subconductors per phase typically used in 400 kV lines? Drop your answer in the comments. So now you know the 3 major types of conductors, each one designed for specific needs, environments, and voltage levels. Solid conductor, simple, cheap, and good for low-voltage fixed installations. Stranded conductor, flexible, durable, and ideal, where movement and mechanical strength are needed. Bundled conductor, the champion for high-voltage lines, designed to beat corona and boost efficiency. Which one do you think plays the most crucial role in the modern power system? Comment below, and let's see who's really paying attention. And hey, if this video helped you learn something new or clarified concepts you've always heard about but never fully understood, please hit that like button. It really helps the channel grow. If you're serious about understanding electrical power systems in a clear and practical way, make sure to subscribe to Electrology. More amazing content is on the way, and you won't want to miss it. And if you want to show some extra love and support for the channel, check out the thanks button right below this video. Even a small gesture helps us continue creating high-quality educational content for all of you. Or better, become a member by clicking the Join button. You'll get exclusive perks, early access to some videos, and a shiny badge that shows up next to your name in comments and live chats. That's it for today. Until next time, stay curious, stay charged,